Good morning. Monday. We'll probably get finished with 3 sheets today is my goal. Take your notes. If you turn in your notes, we won't do an assignment, or if I see your notes, we won't do an assignment to go with this. So, quadratic equations. Solutions to quadratic equations. Read the note examples at the top. The solution to quadratic equations are the points at which each function intersects the what? X-axis. Very good. The solutions are also referred to as what? Zeros. Intercepts, and roots. The word was escaping me for a second. So, number of solutions. If you have a graph that looks like so, or maybe like that, it has 2 solutions. And that's where the graph crosses the x-axis. Right? One solution. That could be where it just barely touches, like so. Or the reflection of that, where it goes up. And no solution can be like that. I should say no real solution, okay? Because that equation actually would have an imaginary solution. So, solve by graphing. Pull out your calculators, your phone, whatever it is you use to graph. I go y equals, and then I say x squared plus 2x minus 3. I graph that. It looks like here it's crossing at -3 and at +1. The vertex here looks like -1, -4. And if I check those on my table here, I will see, yeah, at +1 here, my y value is 0. So 1 is a solution. At -3, y is 0, so -3 is a solution. The vertex, the most negative number here, -1, -4, yep, so that looks just like what I thought it looked like. Admittedly, I've had much more practice than you guys. So the solution here for this is, and I guess we have a space to write it over here, x is the set of all x's such that x is equal to either -3 or +1. Okay? here and here. Does everybody understand how to solve these by graph? Pretty basic, right? So, we'll do one more, and then I'll skip that last one. Let's skip to the third one. It should conceivably be harder. X squared minus 6x plus 8 2 and 4, very good. So 2 here, 4 here, any questions? Pardon? I'm sorry, can you say it louder? Okay. So you can look at your table here to do your graph. The vertex is 3, -1. Okay. Vertex is 3, -1. These 2 points here, this is 2, 0, and 4, 0. If you look here, where this is x, where the y is 0, there's a 2. Where the y is 0, there's a 4. So it's not hard to solve this way if there's a real solution. And it's a integer value. If it's fractional, you can see kind of where it is. Let me, for instance, say, let me change this equation slightly. Let me go to, I don't know, +7 might do it. It does. Notice where the intersection is, it's not a whole number, is it? If I look at my table, it's going to be close to 2 and 4, but it's down 1, so it's going to be somewhere between. Notice it goes from +2 to -2 here, so the 0 is in between those two values, right? So it's going to be between 1 and 2. On my graph, somewhere between here and here, between 1 and 2. Y'all see it? So if it's not an integer, graphing isn't necessarily the easiest way to solve it. Now there's another way we can do this with graphing. Let me show you real quick. I'm going to type another equation here. I'm going to say y is equal to 0. Simple. What does y equals 0 look like? See the red line there? That's y equals 0. Now, if y equals 0 and I have the other equation here, I can find the intersection on this calculator with these. You just hit second, trace, which is calculate. We want to calculate the intersection, 5. Okay? And it asks me, what is the first curve? So what is the first equation that I'm evaluating? And it already says y1, which is what I want. And then it says, what's the second equation? And that is the y equals 0. So that I'm good with that. I want to know where those two cross, and then it says approximate. So I'll move my cursor over there to that first point. I'm going to have to do this twice. To the first point, I hit enter. And it says 1.5857864. So that's fractional. Probably. If I go math, enter, 2. It's not going to work. Let me try again. So graph, second, calculate, 5. enter, enter, enter. I can't get it to pull up the fraction, which probably means that it is not a fractional value. It's an irrational number kind of thing. It's a very difficult fraction to locate. Okay? So, then you can do it again. If you move your cursor over to the other point, second, calculate 5, intersection, enter, enter, get your cursor as close as possible, enter, 4.4142136. Okay? So this will give you an approximate value. It's not the exact value. If you plug this in, most likely that's not going to yield 0. And that's what we want. We want the number that we can plug into that equation and y equals 0. But graphically, that's how we do it. Let's go on. So we can solve by factoring. But it's been a while since we've done factoring, so let's do a quick refresher. Greatest common factor. Take a look at number 1. See if there is a greatest common factor here. 3 goes into both 12 and 18. Goes into 4 or 12k. 3 times 4k is equal to 12k, right? And 3 times what value is equal to 18? So now if I distribute this greatest common factor times 4k minus 6, do I in fact get 12k minus 18? Yes. So that's the solution. Here, 40 and 64. Think 8. 8 goes into both. Is there a bigger number? Let me show you a quick shortcut, easy way to do this with your calculator. If I have both the coefficients of 40 and 64, and I turn them into a fraction and simplify that fraction, math, enter, enter, 5 over 8. Okay? So if 40 over 64 reduces to 5 over 8, what is the greatest common factor for both? 5 times what value is 40? 8. 8 times what value is 64? 8. So if you're not good at factoring, you don't know your mathematics tables really well, that's a shortcut for you. Okay? And you can, even if you need more help than that, you can say 40 divided by 5 equals what, and 64 divided by 8 equals what. You can see it's 8. Okay? So I'm going to factor out the 8 first of all. Then you look at your variables. We have x to the 8th and x to the 4th. So we would go x to the 4th. Sorry. X to the 4th. And then y to the 1st, y to the 1st, so just y. Then, what do I have to multiply by that value to get the original term? 8 times what number is 40? We said 5. X to the 4th times what will give me x to the 8th? We add coefficients when we're multiplying like terms. So 4 and 4 will give me the 8, right? And y times what is y? Just 1. So we'll leave that off. Plus, do the same thing with the second term. 8 goes into 64 8 times. X to the 4th goes into x to the 4th 1 time. Y goes into y 1 time. So we just leave it there. We don't have to do it. You don't remember? Do. Okay, great. So here I see 7 goes into all 3 of these. m, look for the smallest. If you have m to the sixth, m to the third, m squared, the smallest coefficient, or the smallest exponent would be your common term, which is m squared. I can multiply 7m squared times 2m to the fourth, 2 and 4 equals 6, minus sign, 7 times 5 is 35, m squared times m gives me m to the third, that's 2 plus 1 equals 3. And then finally, minus 1. You have to put the 1 in there. If you just leave it off, it's like, oh, it's 1, I don't have to write it down. If it's a placeholder, you do. You have to have some value there so that when you multiply this, you end up with this. Okay? That's one mistake a lot of students make, is they'll say, oh, it's 1, I'll just leave it off. You have to put the 1 if it's a placeholder. Okay? Here, 3, 5, and 8. 3 and 5 are both prime, so there's not going to be a common factor there. But we have a squared, and a, so I'm going to have a in each term. B squared, b, and b, so just b in each term. And then that's 3. We've got the a, so a times 3 is 3a. We don't have to put the 1. Okay? B times b is b squared minus 5a plus 8 . Any questions?
Did you say that was make it b squared?
If you go b times b, it's b squared. Pardon? So, when factoring, always look for a greatest common factor first. Okay? Trinomials. Factoring when you've got a coefficient of x squared, a coefficient of x, and then a constant where a is equal to 1. I'm only going to do a couple of these. If you need more practice, do more. If it's equal to 1, it's not so hard. And here is the way I always teach my Algebra 1 students. I call this the X box. Your teacher probably called it something else last year. Y'all know what I'm talking about? Okay. What you do is in the top box you put a times c, which in this case it's 1, so it's easy. 1 times 45 is just 45. And in the bottom you put the difference, which is 14. So I want factors of 45 that add up to 14. Okay? If you're not good, use your calculator. Divide it by 9 and 5. So 9 and 5 do, in fact, add up to 14, right? But if you don't know what the values are, you can divide it by 2, by 3, by 4, by 5, by 6, until you get to that will do that. Another way to do it is you could just list all the factors of 45. For instance, like 1, 45, 2 won't go, 3 and 15, 4 won't go, 5 and 9, and that's your last one. So which one of these pairs adds up to 14? That's the process, okay? So, what are my factors? I have positive and positive. That means that both of my operations here are plus. 9 and 5 were the two factors. And x squared is just going to be x and x. If I wanted to check this, use FOIL. X times 5 is 5x. 9 times x is 9x. So 9x and 5x does in fact equal 14x. X times x is x squared. 9 times 5 is 45. Pretty basic factoring. Let's find one that might be a little harder. Let's go to the last one here. 5z squared minus 25z plus 30. Is there a greatest common factor? 5, right? So we can go ahead and factor out the 5. That leaves z squared minus 5z plus 6. Then you say 1 times 6 is 6, and negative 5 here is the difference. So two factors of 6 that add up to negative 5. Negative 6 and positive 1, negative 1, sorry. Negative 6 and negative 1. Because negative times negative is positive. That's not right, I'm sorry. 2 and 3. For this to be negative, yeah, both negative 2 and negative 3. Sorry about that. Because this is positive, that means these signs have to be the same. They either both have to be negative or both be positive. When we multiply different signs, we would get a negative number there. So we don't have a negative 6, they have to be the same. This tells me whether they're negative or they're positive. Okay? If this were negative, then the larger value, the larger absolute value would have to be negative. But since this is positive, they both have to be the same and has to add up to negative 5. So we still have the 5 there, but then we'd have z and z, like I said, minus and minus 2 and 3. Okay, so the zeros here, what would the zeros be of that quadratic equation? Anyone? You would set these three factors equal to 0. 5 equals 0, there's no answer there, or just 0. Z minus 2 equals 0, we'd add 2 to both sides, so it'd be plus 2. Z minus 3 equals 0, we'd add 3 to both sides, so it's going to be plus 3. So the solutions here would be plus 2 and plus 3. Y'all remember that? So let's skip ahead. Trinomials where a is not equal to 1. Where a is not equal to 1. This is where the x box value process makes a little more.
Mr. Barnes?
Yes, ma'am.
Someone's here for Heritage Seals.
Thank you. Erica, you can just finish this online. I'll post the recording after class. The key is online as well. you are. Just, you can go through and fill them out. Just watch the videos. Okay, so 2 times 18 goes in the top. This is A times C. All right, so A times C, 2 times 18 is 36. The bottom value down here is B, which in this case is negative 15. Now, I didn't tell you guys, but I looked for a greatest common factor first. There wasn't one. Because we don't have an x in all three terms. We do not have an even number in all three terms, so it's not going to factor. So, factors of 36 that add up to negative 15. This is positive, this is negative, so they both are going to have to be negative. If you want to make yourself a little helper key here, if your quadratic is negative and positive for those two terms, let me take these parentheses out. So if the first sign is negative, the last sign is positive, then that tells us that they're both going to be negative. If it is negative and negative, then the larger is negative. If it is positive then negative, then the larger one is going to be positive. Okay? So in this case, we're looking for a difference. In this case, we're looking for a sum. And of course, if they're both positive, then it's just equal to positive. Okay. So I don't know if you recall that or not. So factors of 36 that add up to negative 15. So we're going to have two negative numbers here. Can anyone think of two factors of 36 that add up to 15? Let's think. 1, 36, 2, 18, 3, and 12. Does anybody see it yet? 3 and 12, right? So if this were negative 3 and negative 12, those would multiply to be equal to 36 and add up to be 15. There's one more step, okay? Then we divide both of these by our A value, which is 2 in this case. Hopefully, y'all are good at this. Will 3 over 2 reduce? How about negative 12 over 2? That equals a negative 6. Okay? So, I'm going to go through this about 3 times, so please pay attention right now. If this simplifies, you just say x minus 6 or whatever. If it will not simplify, okay, then we take this first, or the denominator goes in front of one of your factors, okay? And the numerator is the other value. Here it's simplified, so we just put x minus 6. Do I need to show you guys that this is correct? You believe it. Let's see here. If we go 2x times x, that's 2x squared. 2x times 6 is, or negative 6 is negative 12x. Negative 3 times x is negative 3x. So negative 12 and negative 3 add up to negative 15, right? And then negative 3 times negative 6 is positive 18. Yes, Nathaniel?
I didn't hear you. Why did you divide 3 and 12 by 2?
3 and 12. Oh, these two, that's A, the A value here, the number in front. Because, and basically, long story short, it's because we multiplied it here. Remember, this number was 18. We multiplied it by that 2. So these factors were factors of 36, not factors of 15. So here, I'm dividing them by 2 so that it goes from 36 back to 18. But you have to do that to take into account this coefficient out here. That's where you're going to get that number. The short answer is that's the only way it works, which may be sufficient for many of you. Let's try it again. So what goes in the top box? Well, first of all, do I have a common factor? Will 5 go into these two? No. So we don't have a common factor there. So the top number has to be what? 5 times negative 48, which is negative 240. This seems a little more tedious, but trust me, it's much better than guess and check. The other way many of you have learned to factor is to guess and check. And when you have big numbers like this, I've been doing math a long time. This is the easiest way I know of to figure it out. If there were an easier way, I would change, trust me. I hope you guys have learned that from me so far. He said, I will show you the easy way. Okay? So, negative 240 there. The bottom number is our B, so 22. This one, I'm going to have to write down these factors probably in order to get the result. So let me do that. So down here, I'm just going to list factors. Of course, I have 1 and 240. One of those two would have to be negative to get a negative 240, right? It doesn't matter which one, but one would have to be negative. So let's keep going. I'm going to write it on my whiteboard here. You can write it wherever you want in your notes. Just to keep it from looking too crazy, I'm going to go 1, 240, 2 and 120, 3 and 80, 4 and 60. Now this value is 22, so the numbers are going to be much closer together than what I'm showing you here, right? Let me tilt my thing up a little so you can see.
Dalton Arwood and Kenton Cobble come in my office, please.
5 goes into 240 18 times? No. 5 goes into 20, 48, 40 times. 200, 5 times 200. Sorry. 5 would go into 200 40 times and 48 times. So 5 and 48, we're getting closer. We're still not there. You can always use your calculator. 240 divided by 6, of course, is 40. The difference here, and this was minus 48 and plus 22, so we're talking about a difference this time. It's going to be, we subtract the 2, and we end up with a positive 22. So, we're at 6 and 40. That's not going to work. That's the difference of 36 or 34. Keep going. Pardon? Yeah. So let me list some more. None of those work so far. I'm still going. So we were at 6. 7 doesn't go, I don't think. No. 240 divided by 8 would work, of course. That'd be 30. Wait a minute. 8 and 30. Do those have a difference of 22? Okay, this is positive 22. So I want the number that is larger, the 30, to be positive and the 8 to be negative. Do y'all understand why I chose that? If I did it backwards, it would be negative 22. I want it to be positive 22. So now I divide by what? 5. That one simplifies. This one does not. Okay? So 30 over 5, that's just going to give me, and this is P instead of X here. P is P plus 6. Very good.
And then 5P.
Very good. So you take the 5, that becomes the coefficient of your variable. And then minus 8. If we multiply those out, we get our original trinomial. Have you guys learned something today? You learned it last year? Just refresher? Either way. So factoring a trinomial where a is larger than 1. Again, I call this is my X box. And that's just the term I picked because it resonates with your generation. We called it something else when I was in school.
There's really no like internet again. Or it's not really a refresher for me because it's not math teacher last year.
Let's not go.
It's hard again.
Well, the pandemic slowed things down.
It's
So
just even.
I know some of these things you guys maybe didn't get to.
He just gave us a book full of like he named 200 questions for us to do.
All right. So, keep going. We don't have a greatest common factor here. So, in the top box, I'm going to go 3 times negative 40. It's negative 120. The bottom box, I'm going to put negative 19. It's not really a box. It's a space, but you know what I mean. Factors of negative 20. And notice these two are different as well. So, that tells me that 1 is going to be plus and 1 is going to be minus. So the difference of these two is going to add up to negative 19. So the larger absolute value of the two is going to be negative. Focus, focus. You said you weren't good at this. I'm doing this for you. Okay? So, negative 120, of course, have 1 and negative 120. I've got 2 and 60. I shouldn't have put negative here. We'll just say one of the two is going to be negative. We don't know which one. I did tell you the larger one is going to be negative here, but let's just assume we don't know. Okay? So keep going to, it's going to be closer than these two. So I could skip ahead, but I'm not going to. I'm going to list them all. But if you're doing it on your own, you're like, oh, those are too far apart. Let me get something closer. And you can skip 4 or 5. You know, go to 10. 10 and 12 would be 120. Oh, that's too far. And you can go back. 5. 5 and, well, let's see. We'll just keep going. 4 and 30. That's got a difference of 27. 5 and 6. 5 would go how many times? 24. 5 and 24. We're getting closer there, right? Is that it? 5 and 24. So if we go negative 24 and positive 5, those would add up to negative 19. We divide by 3, and this would become negative 8, and that doesn't simplify. So this is going to be h minus 8 for this one, and this one is going to be 3h plus 5. Try another one. No greatest common factor here. Then I go 12 and negative 2 is negative 24. Positive 5 on the bottom. Factors of negative 24. 1, 24. 2, 12. I'm looking for a difference of 5 because this is negative. One's negative, one's positive. Um, 2 and 12, 3 and 8. Does that have a difference of 5? 3, 8. I divide both of them by 12. Now these will both simplify. One of them is negative. Which one? The 3 is negative. Very good, Nathaniel. Okay? So, we divide by 12. Now simplify these guys. Simplify them. It doesn't turn into an integer, but it will simplify. This would become, yes, negative 1/4. And this one would become 2/3. You'll see that? So the coefficient here would be 4. And, oops, sorry, wrong box. The negative one here goes over here, so this would be 4x minus 1. And this one would be 3x plus 2. Check the math. 4x times 3x is 12x squared. 3x times negative 1 is negative 3x. 2 times 4x is 8x, so negative 3x plus 8x is 5x. And then positive 2 times negative 1 is negative 2. Good? Making sense? Hopefully. I want you guys to try 18. Let's try 18. Bigger numbers. It's not harder, it's just bigger numbers. Try 18. Pause your video if you're at home. Try 18 real quick. Okay. So hopefully you got it. Factors of 864, negative 864 that add up to 60. The one that came to me, I tried a few different ones here. First we multiplied the 16 times negative 4 to get the 864. I tried 8 because I've noticed 16 and 54 didn't have a difference of 60. So I thought a smaller number, 8, was 108. Didn't work. 12 and 72. 12 and 72 do have a difference of 60. Okay? The negative 12, positive 72 would give me the answer that I'm looking for, 60 here. Then I divide this by 16 and this one by 16. 72 divided by 16 is 4.5, so we're just going to reduce that. 72 divided by 16, math, enter, is 9/2. Negative 12 over 16 is going to be negative 4 goes into both, so negative 3 over 4. Okay? So these two end up being the coefficient of my x's, or m's in this case, rather. I have 4m minus 3 and 2m plus 9. 4 times 2, hold on. Oh, reason my values are not working here is I didn't factor out my greatest common factor first. What was my greatest common factor? There was a 2 there, right? So 2 times 8m squared plus 30m minus half of 54 would be 27. And 8 times 27 would have still given me the same factors. Okay? But the difference is I have a 2 out here in front of this. So 4 times 2 is 8m squared. 4 times 9 is 36. Minus 3 times plus 2 is negative 6. So positive 36, negative 36 is 30. And then negative 3 times positive 9 is negative 27. All those times 2 here give me the original equation. Notice it still worked even though I didn't factor out my greatest common factor. The only problem is if I had just written this down, that would only be half that amount. So you still have to have that factor in front for it to be correct. But it still worked even though I started out wrong, right? So that's a really good selling point for this method. Let's do the last one here. Let's look for a greatest common factor this time. And try that one. Pause it at home, guys. Hopefully you've got there. You factored out the 8. Y squared plus 7y plus 12 is the other factor. 1 times 12 on top. 7 on the bottom. Both of these are plus, so both of these are plus. And 3 times 4 is 12, and 3 plus 4 is 7. So that was my factors. So 8 times, the A here in this case was 1. The 8 is on the outside. If you had not factored out the 8, you'd have an 8 underneath here. That's okay. You just have to put the 8 in front when you finish. Okay? Try to remember to factor out that greatest common factor first. But this will give you the result we're looking for. Any questions? I'll do it later in the week. Guys, just hold on to these. We will finish up tomorrow on difference of squares. And I will look at your notes there. You guys at home, just photo your notes and attach it to today's assignment. And I will give you credit for the day. You get 100% participation. If you did your notes, you get 0 if you didn't do anything. So turn something in. Thanks, guys.